sharing my screen. Okay. So in previous classes, we started with RAG, and already many things we have learned in RAG system. So RAG is a retrieval augmentation and generation. Okay. So till now we have seen the different things like we have learned how to load the document. In this we have seen PDF file. Okay, PDF files, how we can load the PDF files. Then second, after loading the document, the next step is chunking. So chunking, breaking the document into smaller parts. Okay. Then we have seen embedding. So different embedding model we have seen. We have seen OpenAI embedding. So OpenAI provide 3 different embedding. Add 002, large and medium. Okay. So large has the dimension of 3072. Sorry, not medium. It's small. Okay. Small. So it has a dimension of 1536, and it is also, I think, 1536. Please check for ADA 002. I think it is 1536, but you can cross check it. Then we have seen vector store. Once we have a embedding vector store. So in vector store, we just started with ChromaDB. Okay. And in today's class, we will see Quadrant DB. Okay. So vector store is what we store in vector DB. Can anyone want to answer? Chitrantan?
Yes, sir.
So what we store in vector DB? Okay, no problem. Anyone else? Aditya?
Yes, sir. Sir, in vector database, we store the numbers which we have generated from the chunked document.
Correct. And that number we called it as a embedding.
Vectors. Yes,
Yeah.
embeddings.
Right. Vector also you can say. Good.
Yes.
Yeah. So till now we have seen so loading the document. Once we load the document, then we do the chunking. Then chunking, we generate the embedding generation. And once this embedding get generated, we store in some database. Okay. This is called vector DB, and we store all this number into this vector DB. Okay. Now the next step is so let's say if you are creating any rack system, these steps need to be followed. So let's say if you have a bunch of documents, so first steps, or let's say if you have to create a rack system, then you have to load the document, do the chunking, generate the embedding, and save into a vector database. Okay. So once you save the embedding in vector database, next thing is you ask some query. Okay. Query. So based on the query, it will provide the relevant document. Relevant document. Okay. So it will provide you the relevant document based on what query you have asked. Okay. So yeah, so this is about a retrieval part. In that also there are some terms. So first let's say vector. Okay. So vector, and there is one more term called scalar. So if you take only one number, that we called it as a scalar. And in a list, if there are multiple numbers in a list separated by comma, then we call it as a vector. Okay. So for example, let's say 0.318. So this we call it as a vector. Okay. This the number of it can have multiple numbers, so it should have a more than one number. Okay, at least two number in a list. If there is a two number, then we can call it as a vector. Okay. Now, so in a space, let's say if you have a two-dimensional vector, right now OpenAI has a if I talk about a 1.5 or a small model, it has a 1536 dimension. Okay. And to plot this in a some 2D plot, it is very difficult. So I'm just taking the example of two-dimensional vector because it is easy to plot. Okay. So when you create a embedding, so and this embedding has some meaning. Okay. For example, let's say if I take few words, for example, apple, I take grapes. Okay. Then let's say queen, king. Okay. Microsoft. Okay. And let's say Google. Okay. And similarly, let's say Pizza Hut, and Domino's. Okay. And let's say if I have to mm, create a embedding, and this embedding is, let's say, two-dimensional. Okay. Two-dimensional means for each word, I can generate a vector which has a dimension of 2. Okay. So, and if I generate the embedding, so now these embedding are very smart, means they able to capture the semantic meaning. Semantic meaning means it able to capture based on
Sir,
what.
volume is very less, sir.
Now.
Yes, sir. Fine, sir.
Okay. Yeah. So let's say uh, sorry. Yeah. So let's say these are the words. Total I have uh, uh, 2, 4, 6, 8 word, right? Total I have 8 words. So there will be, for each word, there will be a embedding. So once we pass this embedding, once we pass this number to embedding model, it will create a, uh, for each word, there will be a some embedding. Okay. So let's say, as I said, this embedding model are very smart. Smart in the sense it will able to capture based on based on the word name. or word, it will basically identify what it represent. For example, apple and grapes. Okay, maybe I'm just so apple and grapes. So let's say these two vectors. So let's say this represent apple and grapes. Okay. Similarly, queen and king. Queen and maybe king, and Microsoft, Google. Okay, and pizza, Domino's. Okay, so this embedding model or embedding model basically separate the word based on the, let's say if they have to place uh, based on the embedding, if I have to place in this into a 2D space, so it will basically able to separate into a different parts based on the meaning. For example, queen and king, if you see, it is basically representing some position. Okay, like queen and king are person who is basically and let's say apple and grapes, this is about food. Okay, so this is about fruit, sorry, fruit. Okay, so and this is about hierarchy of kingdom. Okay, Microsoft, Google is a basically a tech company. Okay, and pizza, Domino's are food company. Okay, so let's say if any new word come, for example, uh, uh, so minister. So minister will go to in which sector? So let's say there are 4 sector. Okay, just I'm taking some example. So let's say this is first, third, and fourth. So minister will come into, let's say if any new word come, so embedding model will place that minister into which sector? Anyone?
First sector.
Correct. So this will put into a minister. Okay. And let's say if pizza, Domino's, okay, maybe Oracle. So Oracle will come into third sector. Okay. It will know, okay, this is a company. So it will place that into a that sector. Okay. So similarly, if you embed any document, so based on the embedding model will know what this document represent or what this document is talking about. So it will place that document or the embedding will be in a such a way that the similar context sentence will be grouped together. The embedding will be similar. Okay. And so, and since it has 1536 dimension, it will be difficult to plot. Um, but just just I want to give some intuition how it look like. So I've just taken the example of 2D. So for example here, queen will be maybe 1 comma 1. Okay, and king will be 1 comma 1.1, and minister will be maybe 1 comma 1.2 maybe. Okay, similarly apple and apple embedding will be, let's say this is a -1 comma uh, minus 0 point sorry plus 0.8. Similarly Microsoft Oracle, uh, let's say Microsoft is -1 comma -1, and Google will be, let's say -1 comma minus 0.7, and similarly Oracle will be -1 or -1.1 or minus 0.8. I'm just giving example. Okay. Similarly, pizza, Domino's. So for each word, there will be embedding, and this embedding will be created in such a way that similar sentence will be uh, uh, the distance will be quite less, but dissimilar sentence. For example, if I talk about Queen and Apple, the distance is this distance is large. Okay, and similarly, Queen and Pizza, the distance is large. So when I apply some sort of, let's say if I have to find similar word, I can easily find, okay, find the closest distance word. Let's say if user is asking something, okay, so again, for example, if I ask some word, maybe fruit, okay, if I inquiry or my query is just, let's say if I have these words and embeddings, and my query is fruit, okay, my query is fruit. So first what it will do, just to find the similar word, so first it will convert fruit into a embedding. Let's say the embedding of this fruit uh, is 0, let's say, sorry, minus 1 comma 0.5. Okay, yeah, thanks. Okay, so let's say the query is fruit, and the first step will be to convert fruit into a some number. So number is minus 1, 0.5. Now if you have minus 1, 0.5, if you plot into this thing, so it will be some, let's say this is a minus 1 and this is a 0.5. Okay, so yeah, so this will be the fruit embedding. Okay, minus 1 comma 0.5, right? Now when so this is a query, so I want to find the relevant document based on the query. So I will calculate the distance. Okay, so which is closer to this. So it will calculate this distance, this distance. So it will calculate the every distance, right, with all the word. Then let's say if you want top 3, okay, so it will find the top 3 or top 3 closest one, and that will be your result. So let's say if you are asking fruit, so then it will tell, okay, now in fruits, based on fruit query, I have apple, um, grapes. Okay, okay, so these are two output it will give. Let's say if you put, so there is a one parameter which we called k. Let's say if you k basically define how many output you want. So let's say if you want 3, so apple and grape, apart from that, it will also tell the third one. Let's say maybe Microsoft is closer to 1. Of course, so it may tell Microsoft as well because you put k equal to 3. Okay, so this is how basically the query happening. Means if you ask any question, so first it convert your question into embedding. Now all these embeddings are already stored, and it will try to find the similar one, similar embedding. So it will try to find the document which has a similar embedding based on your question. Okay, now how to find the similarity? So there are different ways. Okay, um, let's say again if I take some vector, uh, let's say these are two vectors. Okay, maybe a and b. So let's say a equal to the vector, maybe uh, let's say this is 1 and this is maybe 2 and this may be 1 and this may be, let's say, 0.5. Okay, now the vector a will be vector a, basically we represent into x comma y. Okay, so this is x and this is y. So a will be 1 comma 1. Okay, x value is also 1, y value is also 1. For b, the x value is 0.5, y value is 2. So b will be 0.5 and comma 2. Okay, so these are two vectors. Let's say if I have to find the uh, maybe distance, okay, or similarity. Okay, so how we can find the, what is the mathematical expression to find the similarity or distance? Okay, so there are different algo to find the similarity. So one is very famous, that is called as a cosine similarity. Cosine similarity. Okay, so cosine similarity, it basically it try to find the angle. Okay, this angle. Let's say there are two vectors, and if I have to find the similarity, um, so based on the angle, I can find the similarity. Okay, so that we called it as a cosine similarity. So cosine similarity, if I talk about the formula, cos theta will be a. So generally vector we represent as a this. So there is a one arrow. So this we called it as a vector a dot b. Okay, and then there is a basically this is called as a norm 2. Okay, so I will break it down further. So a dot b dot. So there are two things. Let's say if you heard in mathematics, so just I want to recap those things. So a dot b. So dot this we called it as a dot product. Okay, and this we called it as a cross product. So in this case, we will use dot product. Okay. So let's say if I have to do dot product. Okay. So in dot product, let's say if I have a two vector, for example, the same thing, let's say 1, 1, and let's say a value is 1, 1, and b is 0.5, comma 2. Okay. Let's say if I have, no, sorry. So b equal to 0.52. Okay, let's say if I have to do dot product. So in that, what I need to do in, let's say a1, b1, and if there is a a2, b2, and if you do the dot product, so it will be a1 into a2 plus and b1 into b2. Okay, a transpose. Yeah, so it is a summation of you have to multiply and sum the things. Okay, so for example here a dot b. Okay, so it will be 1 into 0.5 plus 1 into 2. Okay, so 1 into 0.5, 1 into 2. So that will be your dot product. Okay, now so cosine of theta. So first thing you do a dot b. Okay, then you do the this thing. Okay, so this norm. So norm is nothing but, let's say the vector a value is 1 comma 1. if you have to find the norm, so these two line basically saying norm. So it generally by default it is a 2. So if you have to find the norm, so it will be square root of 1 square plus 1 square. Okay. Similarly, if you have to find the norm of b, so b will be 2, sorry, 0.5 and 2. So its norm will be 0.5 square plus 2 square. Okay, so that will be the norm of b. Okay, yeah. So cos theta or cosine similarity will be a dot product divided by norm of a, norm of b. Okay, so this we divide this vector a dot product we divide with norm of a, norm of b, just to keep the value between -1 to 1. Okay, so cos theta value means if you have any value of a or b, its value will be lies between -1 to 1. Okay, now let's say uh, okay, so cos 0, let's say cos theta. So when theta equal to 0, when theta equal to 0, so cos 0 will be 1. When theta value is 90 degree, so cos 90 will be 0, right? And similarly, there is a cos 180, that is -1. Okay, so these three value, so at cos 0, its value is 1, and cos 180, its value is -1, cos 90, its value is 0. Now, so when theta equal to 0, its value will be 1. So for example, let's say my a vector is 3, 4. Okay, and v vector is also 3, 4. Okay, now if I do the dot product, okay, so a dot b, so it will be 3 into 3 plus 4 into 4. Okay, so it will be 25. uh, just a sec. Okay, yeah, so it will be 25. Now if I calculate the cos theta, so cos theta will be a dot b and divided by norm of a, norm of b. So norm of so a dot b is 25. Norm of a will be anyone? So norm of a will be 3 square plus 4 square. Okay, so the square root of 25, so it will be 5, right? So norm of a is 5 and norm of v is also 5 because both are same. So if you divide it, its value is 1. 25 divided by 25, its value will be 1. Now, since both vector are same, for example, in this case, let's say this is a norm. Let's say, for example, this is a and the v vector is also here only, just overlap because both a and b are same. So when the both vector are same, cos theta, that is a norm of a, norm of b, will be 1. Okay, now just take the other example. So let's say this, so 90 degree. So 90 degree means its value will be 0, right? Yeah, so if I do the 90 degree. So its value will be maybe for example, let's say if I take this as a -3 and this value is a 4. Okay, so this will be -3 comma 4, right? Now if I have to do the dot product a dot b, so it will be, its value will be -3 into 3 plus 4 into 4, right? So if you add this value will be 0. So they are dissimilar. Okay, now so this is the second case when uh, the two are not similar. Okay, third case will be exactly opposite. So third case, that is for example here we have taken 3 comma 4. So 180 degree means just opposite of this. So opposite of this will be, this is in -3 comma -4, right? So if you calculate the dot product a dot b, so it will be -25. Okay, -3 into 3 -9 -4 into 4, that is, and divided by 25. So its value will be -1. So in this case, it is exactly opposite of in opposite case, its value will be -1. So this cosine similarity, so this we called it as a cosine similarity. So in vector, or if you have to retrieve any document, the most famous one is a cosine similarity. So in cosine similarity, as I said, cos theta is, the formula is this one. Okay, and there is a one more thing, that is a cosine distance. Okay, so in cosine similarity, uh, if I talk about the cosine similarity, higher the value, more similar the documents are, because the highest value will be when cos theta will be 1. Okay, in cosine distance, just reverse. So it will value is 1 minus cos theta, 1 minus cos theta. So this we called it as a cosine distance. Okay, now so these are the two metrics. Apart from that, there is one more metric, that is called Euclidean uh, Euclidean distance. Okay, so right now, uh, in earlier case, let's say for example, there is a vector called a. Okay, let's say there is one more vector, that is b. So a vector, for example, the angle, let's say this is a this value is 3 and this is a 2. Okay, 3 sorry, yeah, 3 2. Let's say this b vector value is 6 and 4. Okay, if you calculate the cosine similarity, okay, cosine similarity, if you calculate the angle between a and b, cos theta, both value are different, right? But if you calculate the value, it will be 1. Okay, because cosine similarity will not see the distance, it will just see the angle. And if you see the angle, because both line are line B is just overlapping with the line A. Only difference is that line vector B length is more. So length is nothing but, if you find the distance between from 0 0 to B, so that is called as a length. Okay, now in this case of in the case of cosine similarity, it doesn't differentiate whether the vector b is larger or larger or smaller. It will only capture the angle. Okay, in this case the angle are same between a and b. Just to further find the distance, so there is a one metric called Euclidean distance. Okay, in Euclidean distance we find the shortest distance between two vectors. Okay, so Euclidean distance is shortest distance between two vectors. Okay, let's say if I have to find the distance. Okay, so what is the distance here? So there is a formula to find the distance. So in Euclidean distance, the formula is norm of a minus b. Okay, so there are two vectors, for example 6 4 and 3 2. Okay, so first let's say if I have to calculate a minus b. Okay, so that is a 6 4 minus 3 2. Okay, so this will be 3 2, right? 6 minus 3 3, 4 minus 2 2. Now I have to find the norm of a minus b. So it will be 3 square plus 2 square. So that is a 9 plus 4, 13. Okay, so square root of 13 will be something around 3.5. Yeah, something around 3.5. So the distance between a and b is 3.5 approx. Okay, so with the help of Euclidean distance you can also find the distance between two vectors. Okay, so in some scenario this is also used. Okay, now again if I, so there are three terms. So one is a cosine similarity. Okay, mainly focus on the value or range. Okay, so this range is -1 to -1 to 1. Okay, so this value varies from -1 to 1. Cosine distance, so this value varies from 0 to 1. Then third one is a Euclidean distance. So this value varies from 0 to infinity. Okay, so in interview they ask means what is cosine similarity, cosine distance, Euclidean distance. They may ask in some candidate they have asked in the past. So yeah, so that is important. Okay, so if you see any vector db, they there you can basically set the distance as well, means which method you want to find the similarity. So these three methods are to find the similarity between the document once you create the embedding. Okay, yeah, so any question on this?
Sir, which method we should adopt with the use case, with a particular use case? I mean, how should we decide which method we have to use?
So most of the okay, so in background you don't have to choose because most of the, so the different vector db uses different method, but most common one is a cosine similarity. Okay, so cosine similarity is most uh, famous one, and most of the time we use this matrix only, cosine similarity. Okay, so 99% cases we use a cosine similarity.
Okay, sir.
So yeah, if I show you the LangChain document, And again, if I go to retrieval, so in retrieval, just go to vector stores. Okay. Or maybe let's say retrieval. Okay. Yeah. So cosine similarity and Euclidean distance. Okay. Dot product is dot product also you can use. That is just to get the angle, but its value, the cosine similarity and dot product is almost same. Only thing is that in cosine similarity, some normalization is happening. Normalization just to keep the value between -1 to 1. Okay. If you do not do that, then its value may varies from minus infinity to plus infinity. Okay. Yeah. So if I show you some document, maybe let's say Quadrant. Okay. So where you see similarity search, okay, so there it means mainly it is basically a cosine similarity. Okay. Um, in some cases, so see here distance dot cosine, right? Vector config distance dot cosine. It means cosine similarity. So all this calculation, this vector DB do, you don't have to worry about the calculation or how just as a user we should know how means in backend what is the logic based on which it able to retrieve the document. Okay. Yeah. So let's go into the code section. Yeah. So this part we have seen. Let's say what we have discussed so far. So first we load the document, then we pass that document, we do the chunking, then pass that document to the embedding model, then we store that embedding into a vector store. Okay. Now when user asks anything, okay, first we calculate the embedding of the question, and then with the same thing, that cosine similarity happening. So this is, let's say for example, vector A, user query is vector A, and in vector store, so there are many vectors, right? Let's say there are um, 10 chunks, so there will be 10 vectors, right? So this query means the user query, it will try to find the cosine similarity from all these vector, and then based on the minimum angle or the value which having higher value, it will give the relevant document. Okay. In some cases, or mm, in vector DB, in some cases, if you see the score, basically they give the score as well. Okay. So in some cases, they use cosine distance, but they call it as a similarity only, cosine similarity. But their value will be, means if the value is smaller, then that is a more similar document. Okay. In case of cosine distance, in case of cosine similarity, the value having higher value, the um, similarity between document will be higher. Means, yeah, similarity between documents will be more. Okay. Yeah. So just to recap, uh, so let's say, so first step is to load a document. Again, I'm just giving the quick recap of um, the retrieval pipeline. Okay. So first you need to load the API key. Okay. Now, so embedding, after that, let's say you upload the API key, I'm skipping the chunking part for now. So just to showcase understanding embedding and vector store. Okay. So here also, let's say for there is a word, I love Python programming. So the embedding will be this way. Okay. Now let's say this is the embedding, text embedding 3 small. Okay. And if I run it, so this embedding get initialized. And let's say if I have to text is LangChain is a framework for building LLM application. So let's say if I have to calculate the embedding. So this means this is the text and embedding dimension is 1536. And let's say if I just printed the first 10 values, okay, these values are look like this, okay, but it will have total 1536 values. Okay, so this is a embedding, how embedding look like. Okay, now let's say compare similar versus different tasks. Okay, so for example, I have taken 3 text. So Python is a programming language. Python is a great for coding, and the weather is sunny today. Okay, and for each text, I have calculated the embedding and store in a vectors. Okay, just created a vector variable and where I am storing the embedding. Okay, and I've also created a function called cosine similarities. Okay, so cosine similarity, it will try to find the cosine, means the cos theta. Okay, so if you see the formula np dot dot, so it is basically calculating the dot product between v1 and v2, the same thing that we have seen in a comma a dot b. So let's say v1 and v2 is two vectors, we try to find the dot product, then lp, then this. So this is the same thing that we have done in seen in the formula. Okay, now so if you see what I am printing, so first similarity score, basically I am printing the similarity score. So first if you see, there are 3 printing I am doing. So first, so let's say Python is a programming language, first document, coding is a second, and sunny today is a third. Okay, thanks. Yeah. So text one, first I calculate the cosine distance or cosine similarity between first Python is a programming language and Python is a great for coding. So that what I am written text one and text two. Okay, so vector 0 and vector 1. Then vector 0 and vector 2. So this one and third one. Okay, and then second one and third one. Okay, now based on the word, let's say, as I said, Python is a programming language, vector 0, and great for coding is a vector 1, and weather is a sunny today. So based on your intuition, what you have seen the formula, which one should have a higher value? Let's say if I calculate the cosine theta or similarity, which let's say if I calculate the similarity between the vector 0 and vector 1 and vector 0 and vector 2 and vector 2 and vector 3. So which one will have a higher value? Which group?
0 and 1.
0 and 1, correct. And if I, and minimum value will be
1 and 2.
1 and 2. 1 and 2 and 1 and 3 that are almost similar, right? Let's see. Yeah. So if you see the first one, the 1 and 2, right? 1 and 2. These are 1 and 2. The cosine similarity score is 0.70. Okay. Now 1 and 3. So 1 and 3 is Python is a programming language and the weather is sunny today. Okay. That value is minimum 0.09. And then 2 and 3. 2 and 3. So Python is great for coding and weather is sunny today. Okay. So here also the value is less, right? So internally this thing is happening in the vector store as well. When we ask some query, so it will try to find the cosine similarity, and based on that it able to find the relevant document. Okay, for example, if I ask Python is great for coding, then it will return the Python is a programming language if I have only two documents. Okay, right. Yeah. Now, so let's see some example. This ChromaDB have already seen, but let's say this is in memory. So Chroma also gave option to store it in memory. Okay, so let's see this thing. So first I need to initialize the means this Chroma model means library. Okay, and if you do the chunking as we have seen earlier also, after that the document will be in this format. Okay, so the document will be a list of, so there will be a list of document. So this is a list and there are multiple document, right? List of document, and each is separated by a comma, and each document contain page content and metadata. Okay, so what I have done, so this document get embedded and stored in a ChromaDB that is in memory. Okay, do not give much focus on whether it is in memory or memory. Okay, just focus on so this document and this document we have done the embedding, and that embedding get stored in a vector DB. Your question may be where we are calculating the embedding. Okay, if you see the vector store chromas, okay, so in that there is a three input argument that we are giving. Okay, so first is a documents equal to documents. If you see, this is the variable where documents is there, and this will only work when the document is in this format. Okay, page content and metadata. Okay, yeah. Now the next variable is embedding equal to embeddings, and where we define the embeddings, if you see this is already defined. So it using this function, this embedding function. Okay, right? And this is just a collection name. Means a collection is some sort of table where you're just given the table name, that the name you can change. Okay, so with this single means vector store chroma, so with this thing you it able to basically do the embedding and store into a vector DB. Okay, so this basically save all these 5 documents into a vector DB. Now let's do the, so all these things are stored in a vector DB. Now if I ask some question, okay, so for example, so here there are total 5 topics, right? LangChain, Python, vector database, machine learning, OpenAI, right? Now you may ask any question, it will provide some answer. Maybe what is machine learning? Okay, and if you see here, so first is a query, and this vector store dot chroma underscore chroma, this you need to put here, then dot similarity search. Okay, similarity search, and inside this there are two arguments. One is query, what question you are asking. Okay, and k equal to 3 means how in output how many document or how many similar document you want. Okay, if you put k equal to 3, it will provide 3 document. If you put k equal to 1, it will provide 1. Okay, so let's see if I change the k value to 2. Okay, and that is optional as well. You don't have to put means if you do not put, that is also fine, means k value. Okay, but let's see what is machine learning. Okay, now it run. Now if you have to see the results, okay, just print. So you put k equal to 2. So what it provide? 2 document. Okay. So this ID it internally generating, but see the answer. So it provide 2 document. Okay. So the first document, if you see what it say, machine learning model learn pattern from data without being explicitly programmed. Okay. And the same thing again it yeah. Maybe it is stored 2 times. Okay, no problem. Okay, so the idea here is, so you ask what is machine learning. So it just given the answer, machine learning model learn pattern from data without being explicitly programmed. Okay, so and if you ask, let's say, tell me about vector database. Okay, and let's say the spelling is also incorrect. Okay, here database, and let's say see what happened. Okay, and let's run it again. And if I see the results, see it able to give you the, based on your question, it provide you the answer. Vector database store embedding enable semantic search over document. Okay, so that is the means you can see how powerful it is. It able to capture the semantic meaning, means based on what context you are asking the question, even if you misspell the word that you are asking, right? Let's say this one, just what is high level. Okay, what is high level? And OpenAI GPT model and Python. Okay, let's say I'm asking 3 questions. In a single question, I have 3 things, right? Let's see what happened. And I have put k equal to 3. So what is high level? So so there are 3 things, 3 output it is giving. OpenAI GPT model are transformed, trained on massive amount. So this is the first thing it is giving. Second thing it is giving, the Python is a high level programming language. Okay, so it give the answer based on what you are asking. Okay, yeah. So this we called it as a semantic search. Okay, semantic search. So you are asking something and based on semantic meaning. So this we called it as a semantic search. Okay, now as I said, you can also get a score. Okay, for example, let's say the same thing that we have asked. Let's say, okay, so here similarity search with score. Okay, see, so OpenAI GPT model are transformed. So its score is 1.2077. Here also same thing. Okay, and 1.28. Okay, so in this case, so this is basically using cosine distance. So value which the lesser the value, more similar it is. Okay, so let's say maybe I can ask almost similar thing. Let's say, okay, let's see exactly the same thing we ask and see the score. Okay. See, the score is 0 when we ask the same question, exactly the same thing that we hear what is written. Like Python is a high level programming language known for its simplicity and readability, right? Because of that, it give the exact same score. Okay, right? Now the third, after that, since we have asked for 3 documents, so because of that only it give the another one and the score is higher, right? So in this case, uh, so you have asked for cosine similarity, but it is actually calculating the cosine distance. Okay. Here the value is, let's say we have seen the value should be between 0 and 1, but there is some extra thing that they are doing, and because of that the value is not between 0 to 1, it is higher than that because this value is score 1.5. So do not worry about that. Main intuition that you should know is that lesser the value, so lesser the value, more similar it is in some. So it is also dependent on, since here we are using a ChromaDB. So ChromaDB is using cosine distance. Okay, cosine distance. In cosine distance, lower score, more similar. If you see here also, na, lower score, more similar. In cosine similarity, higher score, more similar. Okay. Um, yeah, so this is about cosine, means this is how we are basically getting the answer based on query with the help of cosine similarity. One more thing that we can do, so that is same answer you can ask through invoke function. Okay, so just to create an invoke, so like let's say if you have to use a LLM, so what we do, LLM dot invoke, right? So here also you can create a retriever. So this thing you have already, so vector store underscore chroma. So in that function you have defined the embedding documents. Okay, you just make that as a retriever. So as a retriever, and here you need to mention search type and this key value. Okay, so this you have created. Now every time you ask any question, you simply need to do retriever dot invoke. Okay, so that will basically provide you the answer. Okay, yeah, so this is about a retrieval, means this is about cosine similarity and cosine distance. Okay, as I said, some method use a Euclidean, means some vector DB use a Euclidean distance. Okay, and if you see, yeah, so if you see the vector store, okay, so the list is, means the integration, top integration means, so this is about embedding model, select embedding model, and then in vector store also there are Astra DB, Azure, Chroma, Fires, Milbus, MongoDB, PG vector store, Pincon, Quadrant. Okay, so in next class we will see about the Quadrant. So you don't have to learn about all the vector DB, one or two is fine. So Chroma is mainly used for experimental purpose, means just for local use, not we do not use a Chroma in production. Production means a simple, if in company interview they ask which vector DB you have used, don't tell Chroma. Okay, tell either Quadrant, Milbus. Okay, that you can tell, but I will take one, means there will be lecture on AWS. There we will deploy the model, and also we will do all the vector embedding. The model, means in Bedrock also they have LLM model. So we will use the AWS infra to basically do all sort of things. So the best answer will be to give answer that you have used AWS, and in AWS only you have used embedding model and LLM model and vector DB also. So in AWS as well, vector DB is there. Okay, so we will use that. Okay, just for your knowledge, I will tell about Quadrant. So in next class, we will see more about Quadrant, and in Quadrant also there are some terminology like hybrid search. Okay, so if you see here the right side, so there is a dense search, sparse search, and hybrid search, and metadata filtering. Okay, so these four terms are important. They will ask question on that, and it has some extra advantage as compared to normal search. Okay, so the thing that we have done, that semantic search, we can also call it as a dense search. Okay, so there is a um, means both the term are almost same, semantic search and dense search. Okay, so we will see what is dense search, sparse search, hybrid search, and metadata filtering. Okay, so yeah, so after that we will see the generation, the last part of that RAG pipeline, and then we will see um, some we will create some project. Okay, some we do some RAG project just to create a complete RAG pipeline on certain topic. So just I want your suggestion. You basically, let's say if I have to do some project on RAG, whether you want your own document. Let's say if you have to create some chatbot, um, I will see the chatbot that you people have created. Um, but let's say if you want to create some sort of chatbot for your internal document, or the document that you want to basically chat or create a RAG system for your document. So if you want to create a RAG system for your document, let me know. Okay, or it can be a web. Let's say if you are creating a web, mm, if you are taking some website and from there basically you want to create some RAG application. So there we will do the web scraping and uh, create a document and do some sort of filtering. Um, yeah, so I want you people to choose one topic, okay, on which you want to create um, some RAG system, um, and try to make it challenging. Okay, uh, I will definitely try to help you on that, but try to make challenging. Do not put some simple things, and also try to, means let's say if you create any choose any topic, try to see the industry relevance, and also mm, means let's say if you have to create some banking application or medical application, okay, try to create the document by yourself. Okay, by yourself means because this process will help you to answer interview, because in interview they will ask what is the process, means okay, unless you do you cannot answer confidently. So in the process, document creation means data creation. Okay, so data creation is not that you are writing on your own, you are copying some data and create means putting into a structured format. Okay. Um, so that is a document creation. So by next class, I want you people to choose one topic which you think that is a challenging, or maybe your dream to basically create such system on that. Okay. So we will create that with the help of Quadrant DB. Okay, Quadrant vector DB, and we will apply all sort of thing, metadata filtering. Also, yeah, so that will be a long project, 1 or 2 week project. That will you can do it parallelly. Yeah. So yeah, thanks. Adit, you are asking something?
Yes, sir. If we choose a document which has pictures and sort of figures, will it be difficult to do? I mean, can we do that?
So pictures you can do, but I just want to start with some not that difficult because
Text
uh,
based on.
yeah, text based. Try to keep it as a text base for now. Definitely we will
Yes.
see the picture based as well in later classes, but right now no. Okay. Yeah.
Sir.
All people have created a chatbot.
Yes, sir. But not using RAG. Only without RAG
Haha.
we have created.
Yeah, yeah. Mm, I haven't asked for rack and do only what I have asked. Okay. Yeah.
And
I
also
want.
there is memory function in that.
Haha. That also I haven't till now. Right.
Yes, sir.
Okay. Okay. So tomorrow, tomorrow also we can take class. So tomorrow I will focus on, or maybe mm, Saturday evening I will take class. So tomorrow there will be no class. So this RAG thing, it will take I think maximum 3 to 4 classes more. After that, I will start a agentic. Okay, um, agentic AI. So yeah, and once we complete the agentic AI, um, maybe you can start giving interview. Okay, so agentic AI will take I think 10 to 15 classes, and yeah, so and we also do parallelly we do the project as well regarding the RAG, and uh, let's say if the whole syllabus get completed, we will continue with the project. We will do different projects. Okay, so I think November, after November you can start uh, giving interview, and by mid of November we can start creating resume. So I will guide you how to make resume. What are the things that you need to put? Yeah, Adit.
Sir, can you guide us with what kind of projects we should keep in our portfolio in order to make it more attractive and responsive?
Do not worry about that. As I said, after 15th November, we'll start making resume, and there I will tell what to put, what not to put. Right. But if you want, you people can make rough, uh, rough resume. Okay. What you think means? mm, Always put in resume the thing what you have done. Do not put anything which you haven't done. Okay, so do not copy. If you copy also, just check whether you have learned that in a class or not. So start making resume, rough resume. So the rough resume means it cannot be in a some template. You can write in in some pen paper on page. Okay, and take the picture of that. So, okay, let's say if you learn LangChain, Streamlit, okay, Vector DB, Quadrant, ChromaDB, embedding, So this thing you can start writing in your, maybe you can create some note of that. So what you have done, what project you have done. Okay. The project can be smaller, but start putting that as well. Okay. But only put the things you have done hands-on. Okay. What hands-on you have done, because if you put many people just to make resume fancy, they put some thing which they haven't done. And in interview, the interviewer asked question from there, and then yeah, so it make wrong impression, and it is a negative point for you if you are giving interview. um, okay, so better to just put the things that you know, and by the end of this course, you know, means you will be uh, ahead of 95% people. That I can tell you confidently, that you will be ahead of 95% people if you do the hands-on. And the thing that you are learn, many people have heard about AI, um, Gen AI, even experienced people. But if you ask some basic question what you have learned, they may not be able to tell you the proper answer. Okay. So right now, till now, we have seen the base thing. Okay. So once this rack part will be completed, the base is almost done. Okay. Then we will move in a faster pace. Agentic, all this thing will not be that difficult for you to learn. Okay. Yeah. Okay then. Um, thanks. Adit, still you have some question?
No, sir.
Okay. 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 Okay then. Um, thanks everyone. So next class will be Saturday evening. Okay.
Thank you, sir.
Huh.
Thank you, sir.
Thanks everyone.